So we need to prove this integral is equal to this using the area definition. Okay, so limit n approaches to infinity, I is equal to 1 to n. We know that the delta x is going to be b minus a, that's the length of the interval divided by n. So it's going to be f at, if you use the right hand sum, right? Right hand sum approximation, which is the easiest one to write. It's going to be a plus b minus a over n I times by b minus a over n. Okay. See this part here? Or see this? I'm not going to write the limit from here on out, okay? Just assume that it's there. I just don't want to write every single time, just to save some time. So I get, I'm also not going to write the n and I equals 1. Okay, so you should still be able to follow it fine. So a plus b minus a over n I squared times of b minus a over n, right? Okay, so we can bring this b minus a over n at the back to the front because it's not dependent on I. Okay, let's expand the bracket. Okay, and I'm going to use distribution to write this as 3 separate sum of sigma. So, see this? 2a, everything that's not I, I'm going to put at the front. This too, this whole thing here, b minus a over n squared sigma I squared. Okay, so let's use the formulas now. B minus a over n, this is just going to be a squared n, right? Second term, 2a b minus a over n. Sigma I is going to be n times n plus 1 all over 2. The sigma I squared is going to be n times n plus 1 2n plus 1 all over 6. Okay, so let me clean up whatever I see that it's very easy to clean up without too much mess. This one here. And 2 there. And that's about it. So I don't want to make any mistakes, so I'm just going to leave it there. Now I'm going to multiply the b minus a over n inside. Okay, so I get b minus a n times by a squared n. B minus a over n times by another a b minus a times by n plus 1. Okay, again, b minus a. This thing here is b minus a squared over n squared times by another b minus a over n. And we still have n plus 1, 2n plus 1 all over 6 there. So more things we can simplify. N and this n too. Let me combine what I can. So I get b minus a squared plus a times b minus a squared n plus 1 all over n. B minus a, this time is going to be cubed, all over n squared. And we have n plus 1, 2n plus 1, all over 6. Okay, now we have to do the limit. Before we do the limit, let me continue up here. B minus a squared does not get affected by the limit of n approaches to infinity. The second one, b minus a squared. This one you have to divide top and bottom by n. So you get 1 plus 1 over n. This one here, the third term, you gotta divide top and bottom by n squared. And then we get b minus a cubed over 6. Divide n here and in here, we get like that. So as n approaches to infinity, that's going to be 0, that's going to be 0, and that's going to be 0, right? Okay, so we get this as n approaches to infinity. Okay, so reduce. I'm going to first factor out b minus a. They have that all in common. So I get a squared plus 8 times b minus a plus 1 over 3 b minus a squared. So b minus a squared plus ab minus a squared. That, right? So a squared cancels out. Okay, another thing I'm going to do is factor out the 3. So I don't have to deal with fraction inside. So I get 3ab plus b squared minus 2ab plus a squared. Okay, so we get b minus a. Combine these two, you get b squared plus ab plus a squared, right? So if you multiply this with this, that's exactly b cubed minus a cubed. From the, remember the factoring formula for the difference of cubes? That's exactly what that is. So we're done. That's the proof.